Hello everyone. In this episode, we'll go ahead and talk about the TTL feature, or simply known as sometimes TTL Security Check. If you look at Cisco documentation or some of the books, it would be written as TTL Security Check. Before we go ahead and really deep dive into TTL Security Check, it's good to understand a few things. Before we go ahead and really implement TTL Security Check, we learned how do we go ahead and secure our BGP session. So in the past, we went ahead and made use of the authentication. So similarly, TTL Security Check feature is primarily used. It's a kind of a security mechanism, and it is primarily designed or mainly being utilized anytime when you want to protect your eBGP peering session. And if you look at some of Cisco documentation or some of the books or material around this particular thing, the whole idea behind this TTL Security Check feature is to really prevent something called as CPU utilization based attacks. So anytime if you want to protect your eBGP peering session where you do not want any router to be doing any kind of an eBGP neighbor relationship, that's the time we can go ahead and implement this simple security check feature. Now I'm sure most of you already understand what is TTL. TTL really stands for time to live. It is simply a mechanism or a way that limits the lifespan or lifetime of your data in a computer network simply. So that's where we can go ahead and implement a TTL. And I'm going to read one very important line from one of Cisco's documentation that really says how this TTL security check feature really works. So this TTL security check feature really compares the value in the TTL field of received IP packet against a hop count that is configured locally for each eBGP peering session. And that's the main thing when you go ahead and read the documentation, that we will go ahead and configure something called an hop count for an eBGP peering session. And the system is going to compare the value in the TTL field simply. And anytime we need to configure this TTL security check feature, we can go ahead and configure this for either directly connected neighbors, or the neighbors can have a peering session over like multi-hop. Another important thing that we need to pay attention, that both the routers, simply the neighbors, both of the neighbors needs to be participating, like wherever you want to go ahead and configure or change this hop count, that's where we will go ahead and configure on those two routers. For our demonstration, we will go ahead and use two routers in our topology, our router R2 and our router ISP2, let's say for the example. And as I said, the mechanism for the TTL security feature is to protect an eBGP peering session. And I'm sure you remember that between these routers, we have an eBGP peering session already configured. Now we'll go ahead and configure something called a hop count that we heard earlier, that we would be configuring a hop count locally for each of our eBGP peering session. And now let's go ahead and start with doing that configuration on our router R2. But before I really go ahead and show the things on router R2, let me just show you what is the default TTL that is being utilized. So let's go to our another router ISP2 for the time being quickly. And I can go ahead and simply say show IP BGP, and the neighbor in this case is 172.16.22.2, and we're going to go ahead and include something called TTL. So right now you could see that the current TTL values that you see here right now is incoming TTL is 0 and outgoing TTL of 1. Now let's go ahead and take a look at on router R2 before we go ahead and make any change at the moment. So I'll do the simply show IP BGP neighbors, and the neighbor that we are looking is 172.16.22.22, and we're going to go ahead and include TTL here too. So these are the current values which are configured at the moment. So now let's go ahead and start doing the configuration on router R2, keeping this in the mind that this is the default TTLs configured on system, and it's a BGP property, so we need to go under our BGP process. And for which neighbor, as I said, this is for each eBGP session. So for each BGP neighbor, we need to go ahead and configure that wherever we want to implement this TTL security check feature. So we want to go ahead and do that. And now if you press question mark, there are quite a few things that you get to see in this output. And let's go ahead and scroll down. And this is TTL security. So what it says that, hey, BGP TTL security check. So that's how we go ahead and implement. So the TTL security, and after TTL security, we just simply need to configure the number of hops that we are interested in. So let's go ahead and configure a hop count of maybe, let's say 10 for our demonstration. Sorry, I have to write hops and then the number followed by the maximum number of hops, and you can say in the BGP, eBGP, the maximum number of hops are 254. So let me go ahead and use the value of 10 here. And now let's come outside. Now what we went ahead and just did that the BGP session, now we went ahead and changed these hop count between these two BGP neighbors. And this would result in a mismatch of TTL on both the ends. This will go ahead and bring down this is going to go ahead and bring down the BGP session. And the R2 in this case, now the router R2, that's where we went ahead and configured this feature, is going to start sending the BGP packets now with a TTL of 255. And this router has configured a hop count of 10. That means this will go ahead and accept a BGP packet with 254 or more, because as we said, the maximum hop count is 254 and the hops value that we have configured is 10. So if you 254 minus 10 is 245 kind of, and if you start from there, so this is where it will go ahead and start accepting the your TTL or the packets for this particular neighbor. Now we need to go ahead and do the same configuration on our router R2. So let's go ahead and jump on router R2 and we go ahead and go to the BGP process. So we'll simply say router BGP, and the process on this side is 200. We again need to go ahead and configure this per neighbor. So 116.22.2 TTL security and the hop counts again. So we just went and matched the hop count. Now the TTL or number of the hop count or the security, security TTL thing is being matched in both router R2 and router ISP2. This would go ahead and enforce or bring up the BGP neighborship again on this these two particular router. Now we can go ahead and re-verify our TTL values. If you recall, before we went ahead and configured this feature, these were the default TTL. Now just let's take a look at what are our TTL in this particular. And now you could see the minimum TTL is 245 because as I said the maximum are 255. So it will go ahead and accept things between this. So you can see the BGP packets are with TTL number 255, but are going to be accepted with a TTL value of 245 or more because the hop count value is really 10 in this particular. Now we can go ahead and verify the same configuration on our router R2. So let's go ahead and take a look at our TTL in this particular case, and we could see the same thing. And we can also verify that the BGP session should be up now. So we can just simply say show IP BGP summary, and we could see that the BGP session is up actually between these two routers. 172.16.22.22. Yep, that was the one that we had configured. And yep, that's how we can go ahead and verify. Again, the whole idea behind this TTL security feature check is to protect our eBGP based peering session. And one of the specific type of attacks that we prevent with the help of TTL security check, it is simply known as CPU based utilization attacks. And the way it works again, you go ahead and configure a hop count. And once the hop count is configured, again, the hop count needs to be configured for each eBGP peering session. So now if you see that we have a TTL security check between router 2 and ISP2, but we do not have any such thing implemented between router R2 and ISP1. So that means this is per each eBGP peering session. And it's going to simply discard packets where TTL is less than the locally configured value. So that's something we need to keep in mind. Again, it supports both connected as well as multi-hop eBGP peering session. So that'll be all for this episode. I will see you guys in the next one. Thank you.